Good. So we have so far 15 people. I suggest we wait 2 more minutes and then I will kick off the program. Thank you, Marie. We have Olof Sjölén also joining. That's great. We will start in 1 minute from now, so bear with me.
I'm sorry I was late. There was a hiccup with joining.
Yeah, no problem. Everything is settled. So we will give it 1 more minute and then I will
Tomorrow,
start.
Olof.
Morgon.
So yeah, we have a little over 20 people inside. That's good. So in 30 seconds, I will start. Just sent out a reminder to the people inside the project. So let's start. Good morning, everybody. My name is Carl Andersson. I'm professor of pervasive and mobile computing and the project manager for DIT for Bears at Luleå University of Technology. Today, together with partners, we will do this seminar on blockchain technology and smart identification. And as you can see in the agenda, there will be a short introduction by me and Olof. Then I will hand over to Morteza, who is our PhD student at LTU in this project, and then I will hand over to Bengt Gran, who is the founder of Compodium International. Very nice to have you here, everybody. And then, as you can see, also there will be 15-minute slot at the end for questions and answers. We will record this event, if you don't want to be in the recording, you can write your questions in the chat. But everybody who is on screen will be recorded, just so you know. Let me just start the short introduction. Marie, I can share from here, I guess.
Yes.
So I hope it's working. Can you see my screen?
Yes.
Perfect. So just a few words about the project. This is a project funded by the Colarctic CBC program. We are 4 nations active in the project. We have Finland from Lapland region. That's it's Lapin University of Applied Sciences. From Russia, we have 3 partners from 2 regions, City of St. Petersburg and Arkhangelsk region. It's ITMO University and NARFO, and also Russoft. From Norway, we have Nordland Fylke with University in Tromsø, and from Sweden, we have Norrbotten with Luleå University of Technology. We are working with fluid mobility and, sorry, I need to take down this, of people, goods, and knowledge. And we are doing this project during 3 years. We started early last year, and so we are more or less in the middle of the project. We have a budget of roughly 1.2 million euros. So let me now jump to the next slide. We are doing many things, but I would like to emphasize the use cases we have. And today we will focus mostly on the smart ID use case on the lower left in this picture. But we are also working with smart waste, we are working with smart road and connected there. And there will be other seminars covering these use cases later on throughout the project. But we also work with hackathons. We had one in November last year with quite many participants from different countries. There will be a new one that is done from Norway. We have workshops, we do lectures, and there is exchange of students and also PhDs. Right now with the pandemic, we do this more virtually. Hopefully when the pandemic is over, we can start to travel also. But so far we have managed to do everything online. It works quite well. Then I've already mentioned the partners. The overall objectives is to enhance adaptation and transfer of disruptive information technology, including IoT, big data, and what you will hear today, distributed ledger technologies, and also other things. And the project faces the challenges to be relevant in, as I said before, transport, waste management, movement of people and goods within the Euro-Arctic region. I'd like to hear Olof's view a little bit also. I should not steal more time. So Olof, maybe you can say a few words about the technical side we're doing in the smart ID use case before we hand over to Morteza.
Yes, I'm Olof Schulén. Thank you for being here, invited. So Carl and I, we are supervisors of Morteza. So we're very involved in what you will hear next. And it's essentially about how can we use ledger technologies to provide strong global identification. I think you will hear the presentation first, and Carl and me will get back in the discussion section to maybe we can explain more. So that's it from me now.
Yeah, exactly. Thank you, Olof. So by that, I hand over to Morteza Alizadeh. Morteza is PhD student in the Pervasive and Mobile Computing group at LTU, and he is doing his PhD as part of the project. Please join me in welcoming Morteza on the virtual stage.
Hello, Carl. Thank you very much. Can I just share my screen to start presentation?
Good, we can see your screen.
So, hello everyone. I am Morteza from Lulu University Technology, a PhD student in the third years of my program for PhD. So today I'm going to explain and talk about the blockchain technology and a smart identification system. So today I can say that quite many people have heard about blockchain and digital money, and specifically Bitcoin. Maybe many people heard about that. And maybe many people also using this technology in their life. I would like to start my presentation by introduce the blockchain as a tool to establish global identification, and how we can use biometrics and other technology combined with that to make it better system, more secure, and also we can perform against a globally trusted system. So the main question of this presentation that we're going to answer is how we can verify identity, or how we can verify identities, and how to store data decentralized. So my talk will be in 4 main sections, and the first section is about what is the blockchain. and there is some definition, what is a blockchain, and I'm going to talk about what is a decentralized system, and which one is specifically used for blockchain. One example of blockchain as Ethereum, as you can see here, and then I'm going to show one example of the blockchain. Then also I want to explain about the Ipfs, Interplanetary File System, is another decentralized technology that helps blockchain to be more efficient. And then after that, I'm going to talk about the identification, importance of identification in our system, and how would be identification system on a distributed network or systems. First of all, I'm going to define and explain what's the meaning of the blockchain. As you can see here in this slide, a blockchain is a system that contains multiple records, and they are connected together. So we call them a chain of the data blocks, something. And as another meaning, another definition, the blockchain is the linked list of the block that containing three main parts. First of all, digital signed transactions, and then the second is cryptographic, that is the digital money that we're talking, and and then also time stamp. Those are three main parts of the blockchain. So also we are using this type of technology in some environments such as decentralized and peer-to-peer network. So we can say that the result of that is the digital money. We can use that as an example. We can transfer digital money between users. So what is the chain meaning? As you can see on this slide on the right side, we have some documents that they are connected together like a linked list. So we can consider each one as a block, and each block has some information stored inside. So for each block we have some information that I mentioned before. We have some info, we have some encrypted data inside, and also we have a hash code. This hash code is encrypted data, and also we can say that one-way encryption. So this hash code shows is specifically used for each block, and also in each block we have previous hash code that is belong to the parents or the previous block. So as you can see here, we have three blocks, and first block is the initial block. We don't have any previous hash code for that, but for block number 2 and 3, you can see that there are previous hash code inside that it make them connected together. It means that if you change one of them after you make it and create this block, you cannot change, because if you change one of them, it means that you need to change all of the chain and all of the blocks. So also, I'm going to talk about the centralized and decentralized system. In the traditional form of system, or maybe we know some system like a bank system in some countries, we have a centralized system. So on the left side, you can see that we have a user, we have a network, and also we have the main authority, and they are working like on the right side. All users can communicate with this network, with this system beyond the network, and the main authority can manage and control them. So this one is the meaning of the centralized system, means that one centralized authority will manage everything. And also in other side, we have a decentralized system that is quite new compared with the centralized system. So in this type of system, we try to remove the main authority any centralized node, and we are going to distribute all of the nodes, all of the user and all of the application, everything. We are going to separate, and we are going to distribute everywhere. So with this schema and with this theory, we don't have any centralized system. And one of the benefits of that is that if something happened for or failure happened for the centralized, we cannot do anything. But with this decentralized system, we can we have a shared documents, or maybe a shared any shared data on the network. And if something happened for the rest of the network, the other nodes can recover the network. So the risk of the security, it is nothing in compared with the centralized system. So in the decentralized system, we have users, and also beyond that, we have the applications that we call them decentralized application, and we know them as a DApp, D-A-P-P. So a decentralized application is a computer application that usually run by this type of system, and some other system like Ethereum or Bitcoin and something, they have some type of the decentralized application they are running. So we can consider Ethereum as a platform that runs a DApp on that. And also in the Ethereum, we have some definition about a smart contract that I will explain it later. So in generally, we have two types of the blockchain. First is the permission and permissionless. In definition, permission blockchain, it means that all the user to join to network, they need to have a permission. And another one is permissionless, like Ethereum and Bitcoin, two platform of the blockchain. They don't need, user don't need to ask anyone to let them to join and wait for other centralized authority or main authority to allow them to join network. So this is the main difference between two types of blockchain. And usually cryptocurrency and about digital money, we are talking in the permissionless blockchain, not in permission. And usually we use permission blockchain in, or maybe a small system or network, or maybe in some organizations inside, if we have something like internal network. So in this presentation, I'm going to talk about the Ethereum, not about the Bitcoin. Maybe most of us, we know about the Bitcoin, that is also digital, a platform for sending and receiving the digital money. But here I'm going to talk about the Ethereum, and there is a main difference between the Bitcoin and Ethereum, and that's one is the smart contract. So the smart contract is a type of a contract. For example, if some people want to sell and buy some stuff, they usually go to the discussion, and after they agree with the fields, with the mentions, fields and records on the contract, they sign a contract, and then the contract will finish. And after that, we can consider this transaction between two users done. And a smart contract is something like that. That is stored on the ledger on the blockchain and shared on the distributed system. And a smart contract looks like something like this. Is a code that usually store on the distributed and decentralized system. So in this type of a smart contract, this contract usually developer, first of all, design the smart contract with the empty field and upload this to the network, and then user can come and they can read this contract, and if they like to accept, they can sign this contract and do the transaction with that. And for supporting this type of transaction, also there is one website that we, for Ethereum, we have it, EtherScan, that is usually show the recent and recent transaction in the main page and all of the transaction in the history. As you can see here, we have some like a hash code that is belong to them, that transaction, also the block number, and also timestamp that I mentioned that we have those information. And also we have a contract address that shows that where is our contract, where is our main contract, and who did and who signed that. And for using that, we need to also install some application. We call that application wallet. Because for this type of blockchain, we need to have a specific wallet to have our credit inside or money inside. And if you want to just communicate with other, or if you want to buy some stuff, you can log in with your wallet, and you can choose here. You can see that there are multiple networks. You can choose your network, and this one shows your accounts and then your credit, and then you can also do your transaction. And if you just install this application, as a default, you have a send and buy. So directly, you can also send digital money to another user also. So if I want to just explain example about buy and sell with Ethereum, it usually starts by a developer design a contract to buy and sell. Then you have this type of contract as a default when you just install your wallet. You can see on the previous slide, and you have the same here. But if you have your own contract, or maybe you want to use another contract, you can have a notification on your wallet that you are communicating with this contract. So first of all, developer design a contract, then upload the contract to the Ethereum, and then the developer can use that hash code that is a result after that uploading the contract to Ethereum. It can copy this hash code that shows the address of the contract to their dApp or application. And then when other users use this application, they can communicate with this contract directly. So then user can come to the contract. They can also add some stuff or goods to this to this website, or maybe web application. And then another user can come to the website and see the goods that already uploaded by other user. If they accept, and if they are happy that they found their goods, they can also pay by Ether or credit, and they can buy that one. So after those activity, we can consider that transaction is an event is now finished, and the result of that, we have this history of transaction stored on the blockchain, and no one can delete it and no one can change it. So why blockchain? We have some benefits. If we have a blockchain, the first of all, it's immutable. No one can delete. It is secure because no one can delete it. No one can change it. And if someone try to change or delete that one, I mentioned that before, that he or she should have that too much power to change all of the blocks, and it is not possible, or is too difficult to possible for that. It needs too much power for that. And it is distributed, and no third party inside, and anyone can join to this network, and there is no central failure. But beyond that, some advantages, we have some disadvantages. It is not disadvantage, we can call it limitation, scalability and memory capacity. Because for blockchain, if we have a huge network, then for transaction and adding new information, sometimes it needs maybe minutes to finish all of the transactions. So we can say that blockchain is not that much strong in scalable and huge scalable and big system. And another one is each block has some limitation to store data. So this one is another limitation of the blockchain. You cannot store lots of stuff, or maybe some huge data or something like that on the blockchain. So then I'm going to talk about the distributed hash table. It is another type of technology, and it is a decentralized technology that and support the hash codes. It is a distributed system that provides a lookup service. It's similar to hash table, and usually use key values pair that is usually stored on the distributed hash table. So the main advantages of the distributed hash table is that nodes can be added or removed within the minimum time. So this one is the main advantage of the hash table. It is faster than blockchain. So Interplanetary file system is one platform that's created based on the distributed hash table, and this system is decentralized system. And also it has some application. If you want, you can just search on the Google with Ipfs Desktop. You can install this application, and then without any subscription and paying any money, you can have your own you can have your own environment or profile, and then you can also store your information without any limitation. So here you can see that in the Ipfs Desktop, we have some tabs, and you can also monitor your status, like you have your hash code, your address as a peer ID, and you can monitor your network traffic. And another tab, you can monitor your files and folders that you already share or uploaded to this application. And also you can monitor that how many user or peers now are working on the system. On the right side, you can monitor them, and then you can monitor the latency. You can also see the peer ID for other users, etc. So why I explained the blockchain and Ipfs? Because the combination of the Ipfs and blockchain can be a good system with the better scalability and better security and privacy. And also, we are not worried about the memory capacity because we have Ipfs beside the blockchain. We can store big data and huge data on that. For example, like a video and other stuff. If you want to record, if you want to store, we can store on the Ipfs, not in the blockchain. And then also we can store the events of that, the blockchain. So what is the identifications? Is the next topic that I'm going to talk. So identification is the action or process of identify someone or something or a fact of being identified. And as you know that in the blockchain and in permissionless blockchain, anyone can join to the network. So we should, if we want to communicate with other, we should make sure that that user is trusted user, or we can trust them. And then we need to identify ourselves first, and then we can communicate with other without any problem. So the importance of identification in the blockchain is something like these two pictures. If we have a two user and they wants to send and receive, as an example, send and receive money. And for example, if I am going to send the money to other user, I'm not sure that user is trusted or not, and maybe someone had to see something else, and maybe someone steal the computer, and we can. And if I send the money, if this money goes to another person, and on the right side, if I have a wallet, and suddenly I receive some money, and you don't know from where, maybe it is not a legal money that you receive. So this one is identification importance that we should do. Beyond that, as you know, that for identification we have many effort about machine learning. For example, if we have face detection, fingerprints, and other technology, we can use them to identify the user. And as usually, and in this diagram, you can see that traditional form of that. We have the web host, we have a face detection application that user can log into the application, and then after that, they can communicate with the main application that is here. Is example is video conferencing application, and then also they can send their information to the blockchain that this guy with this information at this time logged to the system. So for identification system and the distributed identification system, we have at least three type of the architecture. The first of all, on the top here, you can see the traditional form of that. The user can communicate directly to the database and server, as I mentioned in the previous slide. And then after identifying, he or she can also log to the system. And another one is using some decentralized system. And we have something like separate system beside our system for validating and identifying. So this one looks like a private blockchain or permission blockchain, because in permission blockchain we have some main authority or authorities to verify or validate or credential and or identifications. So on the right side, as you can see, is a new technology, and also we call this architecture DID, Decentralized Identification System. So in this system, all the main authority like issuer, verifiers, and all of the users are in the same network. So if a user published his for example, in that example, we have some sell, buy, and sell. For example, if you want to sell your product, you can put your information on the ledger, on the blockchain, and then other user can come and see this ledger, and there is some signature from verifiers, issuers, and then you know that this verifier is trusted or no, and you can trust that user or not, and then you can communicate with that. So we are looking for some solution to migrate from the traditional form to the new form. So as you can see here on the bottom, you have we should have something like DID, decentralized identifier, and then this DID should be contain two main parts. First of all is a string that is that is specifically used for user and is not similar to other. And there is also the document that is encrypted information inside. So then you can communicate with the system. So at the end of this presentation, I'm going to just show that what is the inside smart identifications like DID. We have issuer, we have identity holder, verifier, application, and IPFS in the same network. And also beside that, on the bottom here, we have a blockchain and a smart ledgers here that shares between. So an identity holder can communicate with the blockchain, store some information there, and also issuer also is communicated, verify also, so that after issuer creates and identities and verified by the verifier, other applications and other user can use that application or information and make trust, and then make trust with the identity holder. And also beside that, IPFS can be used as a storage with no limitation. And also we can use blockchain here to store events that who are communicated with whom, with which goods, something like that. And we can also store time and stamp, some information, address of that identity and other stuff. Thank you for listening to my presentation.
Very good. Thanks a lot, Montesa, for this timely presentation. I think it was very pedagogic, and because it's quite advanced stuff we are dealing with in this project. So thanks a lot again. We move on. We are very good on the clock. We're just following the time scale. So it's now right about time to introduce Bengt Gran. He is founder of Compodium International. He has been very keen on working together with Luleå University of Technology in various projects. So I'm very happy that Bengt decided to work with us in Dit for Bears as well. So by that, I want to hand over to Bengt. Please join me in welcoming Bengt on the virtual stage.
Well, thank you, Kalle. I'm happy to share some ideas and thoughts about the company. Compodium International is a company that deals with secure and trusted digital conversations for sustainable meeting culture.
Maybe, Bengt, you can speak a bit closer to the microphone. It's a bit like you were speaking from the moon.
So there we are.
Yeah, this is better. This is better.
That's better. Thank you. Yes, Compodium International, the communication podium, the stage on which communication occurs. That's the main reason. And well, the company was founded by me many years ago, 1997. So we're actually celebrating 24 years in the video conferencing industry. And over the years, we have grown to be experts and the specialists in telemedicine and e-health, because in that vertical, our customers has learned to expect the quality and also have the ability to pay our invoices in a good way. And I was the founder, and we have our headquarters in Luleå, but offices in Stockholm, Gothenburg, London, The Hague, and we have a daughter company in US. And we are today about 30 people, and we are growing very rapidly right now. And you know, there are a number of elements that lead to success. We have an ID, we have the team, a business model, the funding and timing. And which of those elements do you think is the most valid to gain success? Well, according to research, this is the result. The timing is the most important, and boy, do we have timing in our industry right now. And this means that we have a lot of competitors. We have a crowded market with a lot of players competing on providing services for digital meetings and video conference solutions. A majority of them are American branded, big companies from USA, heavily funded. We have, however, some really good players in this market from China and so forth, but the absolutely majority is located from US. And the market drivers in our market is, of course, the digitalization in general with increased efficiency and the requirements for sustainable working methods, the Greta effect. We must all care for our future generations on this one planet we have. And of course, the global pandemic right now, everything has been fast forward 10 years right now. But we have some wake-up call. The regulatory industry's newly awakened insight into secure digital meeting demands. And of course, we have this legal compliance need, GDPR, Privacy Shield, and also the Schrems II. That has stated that European personnel or European companies are doing wrong by handing over so much personal data to the American companies. Anyhow, Compodium, we look above that premium segment with healthcare, welfare, government organizations, finance, insurance and law, listed companies, and strategic research and development. And those are our customers now. We do not really compete with Zoom and Teams and others. That would be not good at all to say that the small company of Compodium compete with those super giants. No, we are focusing on the premium segment with those kind of specialized customers. And for that, we have packaged a solution under the name of VidQueue, Secure Authenticated Video Meetings. And what is VidQueue? Yes, it's cloud-based video meeting services, end-to-end encrypted. It comprises of a workflow management with front-end, back-end. It's a modular setup, so even small customers can grow with box, like building Lego, and grow with different parts of the service. We have, for instance, lobby for the guests, and of course, multi-point virtual meeting rooms, and the dual level of individual authentication of today. So both the agent that is inviting guests in the system are authenticated, and of course, the guests are also authenticated. And our main is trust. The trust is the absolutely major thing that we are doing here. And today we authenticate individuals in the production today using Bank ID, which works in Sweden. Freja EID also works in a little more geographical context. SITS card, that is heavily used in authorities, healthcare providers, and so forth. And LDAP, an Active Directory, mostly for the agents. And now one-time passcode distributed with SMS for a little bit lower authenticating grade, but in some circumstances good enough. And there are a lot of other trusted methods, Bank ID, I said here, and through partners we can grow with all of those trusted mechanisms around the world. But we do have also, of course, some challenges. We are ready now for an international expansion as a customer. We do have already global customers and partners, but we would like to expand them further. And of course, being a player in this niche, we need solutions at the forefront. And we are now looking to new methods of authentication with biometric, blockchain, and distrusted distributed ledgers, for instance, and see how can we fit that in. And we're also looking into protection against deep fake manipulation. That where you can actually take another person's face and voice and pretend to be someone you are not. And for this, it's very interesting to see whether we can bring partnership with LTU for this innovation support. Anyhow, this secure, encrypted, and authenticated video call for trusted conversations, that is VDQ, we describe further at that web page, compodium.com/VDQ. And as we say, trusted to connect you safely. That is our message, our brand, and bringing minds together. That's also one of our so to speak. So by concluding here, these initiatives with smart identification using blockchain and other technologies is of course very, very interesting in our niche. And we at the Compodium, given the circumstances now, are rapidly growing. And being from Luleå in the north of Sweden with the headquarters, working with the Luleå Technology University is of course a big opportunity for us to further grow and fertilize the innovation process that we are into. Okay, Carl.
Yeah, thanks a lot, Bengt, for this presentation. As I said, I'm very happy that you have decided to work with us. It's now time for questions and answers. Maybe I can start to link a little bit what Bengt already said, that it's many things happening, of course, now because of the pandemic and a huge kind of market uptake. I would like to hear a little bit about the link to Mortesa's presentation, what Compodium can see. You touched upon it a little bit, but maybe you can say a few more words about the potential for using the technologies Mortesa talked about in terms of smart identification, using blockchain or DLT technology together with other means of both storage in terms of IPFS and the identity things we are working at LTU. You can elaborate a little bit on that, please, Bengt.
And especially now with this legal situation where a lot of regulated players in Europe are actually legally forbidden to use American systems. As you all know, this is Zoom. It's a brilliant tool. Boy, it's fantastic, but it is governed under US law. So my face now, my voice, and everything that I've shown now is owned by the American government. That's the fact. And as long as that is okay, I'm perfectly okay with that. Then this is a brilliant tool. But in regulated industries where this is an itching fact, then there must be alternatives, and that is the sweet spot for us at Compodium. And to have a forefront research and to find new solutions that act globally, or at least in Europe, but our aim is to be a global actor the coming years, is very important. And many of those authentication mechanisms build on country-wise, not regional, but national initiatives from government, from tax authorities or local bank systems that then can prove from the third-party perspective that this person really exists and is trustworthy. And this means that we can only expand nationwide where we have this level of trust. Some countries has a long way to go in order to uphold that mechanisms of trust towards authorities. Others, like the Nordics and other European countries, are way on their way. And maybe we in the Nordics here, Sweden, Finland, Norway, Denmark, we are in the top league in the world to trust our authorities. We pay tax and we trust that we have a return in welfare. We have zero corruption and so forth. So in order to expand the possibility to use, to go global, we must look about alternatives to those national solutions, and therefore to have the insight of these global tools is of most importance for us. And we must also learn more, of course. We are in a learning curve as well.
Yes.
So the globalization and well, our situation in Compodium really gives us the possibility, or we are kind of obligated to be in the forefront and learn. So the relation with the research and the academy, I think, is very, very important.
Nice, very good to hear. Thanks, Bengt. We open up for more questions. You can write it in the chat. And if you want to talk, we can also open up, so we allow you to talk also. So anyone, go ahead. We still have 10 minutes to answer questions. I think both Bengt and Morteza are prepared. So don't be shy.
Huge.
We have roughly 25 people in the webinar, so we are very happy for that.
While we're waiting for questions, I can say
absolutely. Go ahead, Olof.
So we are at the forefront of understanding technologies for doing these things, but it's also very important to be humble and understand that the technology issue is only one thing. It's a societal issue about trust that Bengt mentioned that is really the critical thing here. Who do we want to trust? And the world has a long history of decentralization. The whole internet is essentially decentralized. And the early applications too, like email and the World Wide Web. Nobody owns the World Wide Web. Anyone can set up a server and post content. So that means that it can grow quickly and independently and scale excellently. If you want to control the web, you can't, but you can do it on the next level. If you're a network operator, then you can set up firewall and you can ban certain servers, blacklist them, and stop content that way. But that has to be done by each operators in each country, for good and for bad. They can essentially protect their countries from content coming from abroad, which is happening in parts of the world today. The other side is having centralized systems like Facebook, and the second wave of the internet was centralized, coming very much from peer-to-peer. That was decentralized, peer-to-peer file sharing. You could share anything, and actually a lot of illegal content or DRM content was shared, and that spawned a start of file streaming, content streaming, which is centralized again because there is a player that is accountable for that streaming. And the same with the cloud and social media, they're all centralized, which many governments like because they can talk to one player to block sites like Facebook and Twitter have been doing recently. Those things you cannot easily do with a decentralized system because there is no one player to talk to. You have instead to go to the network level and try to block things that you don't want to see, as I explained earlier. So we're going back and forth in the world between decentralized systems and centralized, and they both have their pros and cons. And independently of what you choose, technically, you have advantages and disadvantages from a social point of view, depending, for example, on whether you trust the company, trust your government or not. And the situation is very different in different pieces of the world. So I just wanted to lift this, that this is not just a technical issue that we can solve. It's massively complicated. And one solution doesn't fit all. So there are two sides of it always. If you're completely anonymous, that's a haven for the the traitors and for illegal business also, as you know. If you have insights, then governments can trace illegal business and track down on it. But then, of course, you don't have full privacy anymore. So this is in line what you said, Bengt, but I just wanted to emphasize that there is no one simple solution.
No,
Do you agree?
definitely not. Yes, indeed. The world is more complex than ever. There are so many links in the whole value chain in building trust. So indeed. And one thing that has struck me also that with the provider and now we have a number of often free markets in each individual countries. So if one telecom operator fails to do the job, we can lean on others. But now we have this global coverage ambition from Elon Musk, the Starlink, with thousands of small satellites providing internet capacity for rural areas in Africa and those underserved countries with a thing that we take for granted, high bandwidth access, 4G and 5G access nowadays, which is a brilliant idea to run over not terrestrial or from space down. But that also imposes a monopoly situation where you can govern the access and whitelist and blacklist servers. What's your, Olof, as being a professor in these systems, do you have some ideas about the Starlink initiatives and the pros and cons from that? Unmute your microphone,
Cannot
please.
hear you, Olof.
Yeah. So I don't know if I have any additional information, but I think you always will have these two sides of it when it comes to identity, for example. Of course, our most solid trust today, if we live in Sweden, is with our government through our personal number and our passport, which you can go to a bank and get a bank account, and then you can get bank ID. So it's firmly anchored in your personal number, step by step. And in other countries, this is not at all trustworthy, as you know, and the government will even suppress some people's opinions and so on. So there you would like a completely different model. And I don't know really what to say. What we are investigating in our project, I think it's massively interesting from a technical point of view. And I think it has great applications, being a trust anchor, where you have a blockchain and IPFS system that provides the trust in a decentralized way. But in Sweden, frankly, it will not, for most people, provide the same level of trust as our traditional bank ID is doing, because it's so firmly anchored in our personal number and so on. But in other parts of the world, it may provide better trust than they ever can get from their authorities. So,
agree.
For global coverage, I think technologies are important, but maybe they will have problem taking off in certain countries and easier in other countries. What do you think, Bengt?
Good.
Okay.
Quick answer from Bengt.
Yes.
So we have 3 questions now in the chat, so we need to move on a little.
Yeah, let's move to the questions. Is the cloud-like implementation meaning that your system integrate with a centrally federated or orchestrated infrastructure? I think that is for me. Well, our infrastructure is built on our own servers located in co-locations. We have 2 data centers in the Nordics that is load balanced and so forth with 99 plus a lot of 9s there with the uptime. And our mechanisms to reach authentication engines is also based on that we use a number of other parties that are, so we always have redundancy for the authentication mechanisms to ask, is this person really the person he or she claims? If a doctor are going to meet a patient and they are going to make notes in the patient data records, maybe a changing prescription doses on the outcome of the conversation, and by the end of the conversation they reveal that they are talking to the wrong patient, that would really hurt the trust of the healthcare system and also could jeopardize lives. Absolutely. So that's very important.
Good point. We have also Laura Mäki. She's our project officer from Lapinlito in Finland. Great to have you here. she has a question. First of all, some nice words, very good presentations from Mortesa's side and Bengt, very pedagogic. But she asks about, would this benefit end users and the remote region, for example, what we have presented here, the Colarctic program region. I think we can answer together that, of course, what we are doing now, it's a lot about connecting people. It's about using DLT technology, smart identification, for example, for e-health, as you said, Benkeron, that your company is working a lot with. So I would say yes to that question. The pandemic has learned us a lot about using new tools, even on a more broader scale, and to actually, the digitization has taken huge steps forward in the past year. And this is, of course, important everywhere, but not at least in a sparsely populated region like the Euro-Arctic region. So absolutely, Laura, I would say yes. We have also one question from Örjan Fallheden. Will you adopt blockchain and IPFS for IoT environment in DIT for BS project? Is there any good existing examples? Maybe Mortesa can start. We can fill up after.
If you want to consider that IoT devices and environment that's we have some smart devices and all of them are connected in the network. So if we want to consider that, if we need to store information on the decentralized system, then we can use IPFS for that. Then also, if I mentioned when I mentioned that we have no limitation of the capacity for memory capacity, and also we have a more secure system, so we can cover some security issues and memory issues by this system.
Yeah, I would say I'm in line with you, Mortesa, but essentially the blockchain is not suitable for storing huge amounts of data. And most IoT applications is exactly about that, storing sensor data, massive amounts. So the blockchain shines when you need to do transactions and clearly notify an event. For example, I send money to Carl. That has to be beyond any doubt recorded so that the money is no longer with me, it's now with Carl. And those kind of events are normally fairly few in IoT scenarios. But when they occur, then the blockchain can play a difference there. But I think IPFS is more apt in general for storing IoT data and handling and providing IoT data.
It's a good combination that we have found.
Yeah,
very good. It is now 9:30 plus 2 minutes. So I thank again the contributors here for a very nice talks. I thank also all participants for nice discussions, and we will get back soon from the DIT for Bears project with more webinars and different types of activities. So stay safe where you are and keep in touch. Bye-bye.
Bye-bye.